Hey team, so Diva here can also help you when you're making equivalent fractions. She can also help you make an equivalent fraction that is smaller than your original fraction, right? Which comes into play very often when you're working with fractions because as you add fractions together or you do whatever operation you're doing with them, oftentimes you'll end up with something that can be simplified, right? Or reduced. And you'll hear that really often. So Diva can come into play to help you with that process. So it's the exact same process. She is the exact same Diva, but this time, as you're thinking about a fraction that you're starting with, like if we start with 9/12 here, we want to make our fraction smaller. So as we think about the Diva, right, here's our Diva. She is number one. The value has to be equivalent. Whatever's inside of Diva, her outfit has to match so that it equals 1. So you could have 9 out of 9, you could have 100 out of 100, you can have 2 out of 2. Those are all equivalent. If you have 2 out of 3, that's not a Diva outfit because it doesn't match, right? It's if you do something different to the top and the bottom, your numerator and denominator, you're going to be operating to create, maybe you're going to be dividing to make a different fraction, but it's not going to be equivalent. So a Diva is only legal, right, to create an equivalent fraction when what's inside of the 1 frame here is the same. So we're going to make this smaller. And in this specific case, we're going to make it a specific amount smaller because we're starting with 9/12, right? 12 being the denominator because it's the total amount of pieces that this is chopped up into, and 9 of them are colored. And we want to find out, well, how many, right? If we divide it by a certain Diva, how do we get this? So we want to end up with 1, 2, 3 colored in out of 1, 2, 3, 4 total pieces. And the question, right, the mystery that we're trying to solve now is, well, how did we get that? What did we do to both the 9 and the 12, the numerator and the denominator? That is the same thing. So we can say, well, 9 divided by something, some mystery is going to get me 3. 3, 6, 9. Oh, well, I know that it's 3. Without even doing any math, right? I know that what has to go down here in the denominator spot is another 3 so that it equals 1. So that whatever we're doing to the top, it's legal to do so long as that same thing happens to the bottom. You can do that same process throughout here as you're thinking about creating equivalent fractions that are smaller than your original. So you want to find out, well, if we start with 10 pieces, we now, as I count them, we have 5 and we have 3 that are colored in. So the fraction, the end fraction that we want to get to is 3/5. How did we get there? Well, we used a Diva, right? We used a 1, the identity property, to get us there. So 6 divided by what mystery, right? And just for consistency, if you want to think about this like a 1, some people like to call it a mannequin, right? Here's the 1 mannequin, Diva's mannequin. What outfit can she wear, right? So she goes to her closet and she's like, well, 6 divided by what gets me 3? Well, I know that 6 divided by 2 gets me 3. So whatever we do to the top, we have to do that same thing to the bottom. So she's wearing her tutu right now. So 6 divided by 2 got us 3. 10 divided by 2 got us 5. So 6/10 and 3/5 are equivalent fractions, but 3/5 is the simplified version.